Alrighty, let's go live. Hey everybody, the Network Berg here, third stream, welcome. Um, Sorry if the intro video, it may be something annoying or if it's new, but it's something I'd like to add to the streams before I actually start streaming. So that gives people a bit of a chance to just join the stream, get comfortable, and, you know, just be prepared. So welcome everybody. I've already got Eve open. And I've got the lab selected that we were working on last time. I haven't made any changes, so that lab is exclusively for the stream so that we can mess around and do whatever we feel like doing. Let me just make sure that I'm not muted. Yeah, I'm good. All right, perfect. So I'm just going to put on some game soundtrack music and let's actually play around in Eve a bit. Okay, first things first, let's just open up our lab. And let's see what the heck is going on here. Let's just zoom out a bit. Okay, so we've got all our nodes. If I remember correctly, we added a bit of MPLS and some BGP just between this AS and a customer site. Oh, and we gave 3 customers internet access through our little MPLS network that we built. And we decided, okay, cool, this is what we want to do in life. We want to build ISPs and you know, live the good life. So let's build some more interesting stuff. I just want to see if I can access all my routers quickly. So hang on. I might have to just switch the screen quickly. So I'm not really going like live again in 5 minutes, so just bear with me a moment. This is just something I need to check. Okay. Alrighty. We're back. I just wanted to get Winbox ready. And it is ready. So we've got router 2, router 7. Just want to see, are these the routers that we added ROM onto? I'm not sure. I believe I added ROM onto all of the routers, if I'm not mistaken. Let's just, oh, but I'll only see these 2 because these are my only 2 neighbors. So let's just connect to ROM on one of the routers and see what devices we pick up. There we go. There's all our routers. So we've got our CPEs, we've got our little ISP network. So everything looks good. So we could definitely introduce a bit of a IXP. I was thinking about adding something here before the stream, but I don't want to fully focus on the IXP stuff yet. There's a lot we actually still need to do on this core network to get things running smoothly. But as a base, let's just maybe quickly delete this intranet node that I've got here. And then for router 7, I'm going to create another little block. And this block we're going to simulate or emulate IXP or maybe a transit network. So, you know, you're getting a intranet link through somebody else and you're actually learning your internet routes. So it's very hard for me to actually emulate that because I'm not actually peering with the transit. But we can act as if we're learning internet routes. So it's the next best thing, but it's still pretty good. Let's just change a few of these colors, maybe make this something else. Give that a nice red color. Let's bring up another MikroTik router. And in this MikroTik won't be beta, it will be a normal MikroTik. 12 ports. Let's just call this IXP, I guess. Nice. I just want to see something. So those are all my raw OBS videos. I just want to pick up a cool thing that I like adding on my Eve topologies as well. So let's just start this up. So while this IXP is starting, cool thing in Pro, we can right click, go into the text, and then from the text I can remove the actual text, and if I click on this image I can actually upload an image. So let's just go here, in my downloads, I've got a nice PNG of a cloud. So let's just upload that. And now this is a very big cloud, so we probably just want to set some stuff in the properties. Maybe make it a little bit smaller. That looks a bit better. And now we could hide that router behind this cloud. And then that looks pretty cool. And then I'll add more text, maybe make this IXP now, make that bold. Font, let's use Comic Sans, because that's a good font to use. No, I'm not going to use Comic Sans. Give it a purple color. I do want to increase the size though, that's really small. How's that? Maybe a little bit more. Let's just make it 36. That looks good. And let's just bring that to the front. So with this, you'll see what I'm going to do in a second. Though I might have to move this cloud and IXP nonsense away for a bit. So let's just connect that to our router 7, because that is our ASPR actually. That's going to be peering with our public intranet. And it's going to get to other peers later on as well. I've got this whole thing envisioned. So let's say from the IXP on Ether 2, going to Ether 3 on router 7. Actually, let's make it Ether 10. Make it something interesting. Save that. All right, that's good. That looks good. I just want us to assign an IP address as well. So typically when you do peer at the intranet, you would use not private IPs here, you'd have some sort of a public IP, but I'm just going to emulate that using an address that's not really made for it. Maybe you've seen this address if you do some stuff with DHCP 169.255. So I'm going to act like this is a public IP pool 00/30. Maybe make that bold as well. No, that looks a bit bad unless I increase the size. Or let's change the color as well. Make that nice red, light red. Let's just duplicate that. Let's make .1 the IXP. And .2. I'm not going to worry about recoloring it now because I see it's lost its color. But that's not really important. Let's say .2 is our network. .1 is our transit network, the guys we're going to be peering with BGP. I might want to move that a little bit closer. And before I put that cloud back here, let's just add our intranet, which is this globe. And we're going to use the management bridge. Add this. Now we've got the intranet there. And that's going to go to Ether 1. So right now we don't have any intranet on this network, but we're going to fix that up in a jiffy. So let's just throw the cloud there. Make the IXP there. And if I actually go into my neighbors now, let's disconnect from the ROM on. Look at my neighbors. I should see the IXP. Yeah, it's just called MikroTik at the moment. So let's just connect to that on Winbox, even though I like working on CLI. So the IXP is already, it's going to the intranet on its Ether 1. It's picking that up over DHCP. We can leave all that stuff as is. It doesn't bother me too much. I just want to add a firewall rule from here for natting so that we can say anything that's leaving over Ether 1 to just get masqueraded. And this is just to emulate this. Cool. Now, let's just do a few of the other base things that I like doing. So system identity. Let's just set the name as the IXP. Let's maybe enable the ROM on. So tools, ROM on. Enable that. Apply. And now if I connect on the ROM1, I should be able to get to all of my routers again through Winbox on ROM1. Awesome. Now, I still won't have any internet because this IXP, it really doesn't care about any of my private ranges that I have. And previously, I was just breaking out directly from this ASBR or router 7 towards the internet, but we're going to change that now. So typically, you'd have this peering link with your transit network or the internet exchange point. And on this peering link, you'd probably be configuring BGP between the two providers. So let's do that. So this is AS65000, and our IXP might be something like 65100. Awesome. So let's go back to Winbox, and in Winbox, let's just go into our routing, go into our BGP. In our instance, let's just add a new instance. I'll call it AS65100. The actual AS will be 65100. Our router ID. Now, this is interesting, but I'm just going to, for the example, 255.0.1, make it this link IP. I'm going to not do any of the redistribution from here. And I'm just going to apply for now. So now we have a routing instance. So from the instance, let's just create a peer. Our peer will be peer to, let's call this ISP1. So this little block on the left will be ISP1. We select our new instance that we created. Our hey Rodney. So our remote address will be 169.255.0.2, which is the IP address on the ASBR router 7. Our remote AS will be router 7's AS, which I also need to configure on router 7 still, 65000. And then what we can do is I'm not going to send out a default route, because what is going to happen, I'm going to apply this just to get the base BGP up and running. So let's just create two windows. Let's say the router on the right is now our IXP. Let's open up another Winbox session to router 7 and configure that quickly. So router 7, we're connecting to you. And let's just get these two windows side by side so it's nice and easy to work with. I'm dragging the wrong window. I'm still dragging the wrong window. Let's just close all of these windows. There we go. That's a lot better. Cool. So we've got our two boxes next to each other, and we know the right router is the IXP, the left router is our ASBR. So let's go into the routing on router 7, go into our BGP. We don't have the instance yet, so let's call it AS65000. 65000. Router ID. Now, for the sake of my backbone, I'm going to make this the loopback address, which is 9.9.9.7, because we are going to use this for some future services that we're going to be delivering. We're not going to redistribute anything here. We'll leave the routing table as main because that's where it's on. So let's apply that. And let's add our peer quickly. So, oh, sorry about that. Our peer will be peer to IXP. Our instance is the AS65000. Our remote address 169.255.0.1. The remote AS was 65100. And I didn't specify anything else here. But we're going to do something very important, and I want to almost tell you it needs to be enforced. You always need to do this if you are peering with a external. Like you should do this even inside your own network, and that is working with route filters. We did a bit of that on the last video. But if you accidentally leak routes to the IXP for ranges that don't belong to you, you're probably going to get into a little bit of trouble, because that's known as route hijacking, and it's frowned upon quite badly if you even if it's an accident. Like, people get it, but you could cause a lot of unintentional harm, and that sucks. So please, filters always important. You always want to have them on. But let's apply this just to get the peer up so long. So we should have a peer coming up. I don't think I've applied IP addresses yet, so I'm actually being silly. So 169.255.0.2/30 on Ether 10. And have I applied the IP address on this router? No, I haven't. So 169.255.0.1/30. And that was on Ether 2, I believe. So if I look at my peers, let's just disable one, re-enable, see if we can force. There we go. So now we are established. Fantastic. So I'm just going to minimize that, because now we have a peer with the IXP, but I'm not like, I don't have any public IP addresses yet. Actually, I do have this one public IP, the .2, which I could actually NAT out from router 7, and there would be intranet. But typically, if you're an ISP, you would be going to like one of the registrars or the people that you apply to get public IPs from, as well as where you get your autonomous system number from, your ASN from. So this might be in Africa, we have AfriNIC. I think you've got RIPE and AppNIC and those places where you can apply for your IPs and your ASN. And typically what you do is you'd say, hey guys, I'm an up and coming ISP. I would like to get some public IPs, because I think this is the big thing that stops a lot of ISPs from actually becoming ISPs. They don't know, or they're not sure what the process is in getting your own public pool, how to apply for ASN, and it can be a bit intimidating and daunting. But typically there are people that can help you. You just phone them at those places. They'll send you like a form. They'll ask you, why do you need public IPs? What are you going to do with the public IPs? Are you going to like assign public IPs to clients when they connect over the triple PoE? Or are you going to map some public IPs for customer servers? Or maybe you're doing hosting for customers and you want to, map specific public IPs to clients. You'll have to just give them those reasons, because that would help you with your application when you're trying to get your own ASN and your own public IP pool. But I don't want to make it too much about that, but that is a bit of the process involved when you want to transition into an actual ISP. But we've got a little IXP here now, so that's just an internet exchange point. And we do have our own AS or ASN, which we applied for from those guys, and they've given us a public IP pool as well. And this public IP pool, let's just duplicate that, and that is going to be 169.255, let's say .100.0/ let's keep it small, make it a /24. Very easy to remember and work with. And that is typically a small pool size that you could apply for. You could apply for maybe a /22, but as everybody's aware, less and less public IPs are available that they can assign to people. So don't get upset if you don't get an IP because they can't give you one. It just happens. They might give you a very small pool. Okay, so we've got our own public range that's been assigned to our ASN. We've registered for it. Now what we could essentially do is on router 7, let's just first broadcast this out that this is our public IP. So what I'll do is in the networks, I'm just going to add that network on BGP, 169.255.100.0/24. So we'll apply that. And once I've applied that, if I go to the IXP and I look at my routing, I should actually learn some prefixes. I might just have to force it. So let's just refresh, resend. I might just kill the peer and bring it back up. And let's see what happens. Because I'm actually expecting that range. Oh, I'm so... No, I should see it. I just think I'm advertising the wrong range, sorry. Let's see. 169.255.100.0. I know what's going on. So I don't actually have this IP configured anywhere on my router yet. It's not being used. So when you put the networks here, there needs to be some form of a reference for this route. So the easiest way for me to make this work is just to quickly create a loopback interface. So let's call this maybe L01. Apply that. And then on L01, I could assign the IP address. Let's actually, yeah, the synchronize you can, it should be off actually. I'm just deciding where I want to put that address. If I actually want to put it on the loopback address, or if I want to show you guys something regarding intranet. I think I want to do that rather. So what we'll do is I'm going to assign a new VLAN. And this VLAN, I'm just going to look at my mapping quickly. I've got Ether 1, 2, and 10. So let's say Ether 3 might be going to a switch somewhere. And that switch would be connecting to a firewall or something where I'll be running my untrust services from. So I'll go into my IP addresses, or first my interfaces, and then from my interface, but you don't have to do this with the VLAN. I just like having a specific VLAN associated for my intranet or my untrust traffic. So we could make this VLAN 5 or 99. Let's make it 99. Slap that on Ether 3. And let's just call this untrust. Apply that. And now that I have applied it, if I go into my addresses and I assign 169.255.100.1/24 to my untrust, and I apply that, I'll have a reference for this in the routing table now. Let's just see 169.255.100. There we go. So if I go back to the IXP, now we're learning that BGP route from our peer. Awesome. That's perfect. Let's just be sane and disable the synchronize. I know it might bug some people. It does bug me now actually, because typically you do leave that off, but you can have it on as well. As you saw, it was working just fine. Okay, so now we are peering with the IXP. So the example that I quickly just want to say to some people that might be watching that don't understand what I'm talking about, we might have BGP configured on this network, and for whatever reason, we tell people 8.8.8.8, and we apply that. And now I'm sending 8.8.8.8 to the IXP, and if things aren't configured properly, then other peers might learn, if you want to get to Google's DNS server, then you can come to my router, and then you just broke a bunch of people's DNS because maybe you don't actually have a way to get to 8.8.8.8. So let's fix that, and we can do that by simply adding a route filter. So we'll go into our filters, and in our filters, let's just call this IXP out. And then typically what I'll do is I'll just set the prefix of the things that I want to send out. So I want to send out 169.255.100.0/24. And that I can set to pass through, or let's just say accept. And you could set some BGP actions here as well, but it's not too important unless you've got some failover set up. But maybe let's set that. So let's make the med 1000. Alright, so we have a chain that says this public prefix of ours, accept that. But on the other hand, we can use the same chain, or we could be quick about it. Just copy this, cancel that, and then we can just discard anything else. So what the rules are doing now is it will say anything on that public range we'll accept, and then anything else we will discard. Is it working yet? I doubt it, because I'm still seeing that 8.8.8.8 IP on my IXP. So we first need to just apply that out filter. So let's apply it to our peer. And you have an out filter and an in filter. Again, very important. Out filter is for the routes that you're sending out from your router, what you're pushing out, what you're telling the other network, hey guys, these are my networks. To get to them, come to me. So if you specify your out filter, you could manipulate or state different things to your peer. So I'm going to use the IXP out. If I set the in filter, I could possibly drop specific routes that I don't want to learn, which is very beneficial on the IXP level, because there's some stuff that they call like bogons and whatnot that you don't want to actually get to. So you could just set an in filter for that, so you'd never actually get there. But let's apply that. And you saw everything dropped for a second because the BGP peer actually reset when I changed some of the settings. And now that the settings have changed, now I'm only learning this public IP range that I've assigned. Let's quickly do a test. Let's see, can I ping 8.8? I'm going to be able to ping it because there's a route for it on my routing instance. But let's ping, actually let's just check IP routes. If we look at our main routing table, there is a default route that pushes the traffic out to something that doesn't exist anymore. So let's just disable that quickly. And it's not going to work currently because I'm not learning any internet routes. But we can act as if we were by just going into our routing, our BGP. And what I'm going to do is on the IXP, I'm just going to send out a default route now. So what this will do is the IXP will tell my ASPR, my border router there that connects to the IXP to get to the internet, come to me. Now let's get back to our routers. So we're able to learn about that default route. So let's just see, can we ping 8.8.8? We're able to ping 8.8.8.8, 8.8.4.4. So we can ping that as well. So essentially what is happening, traffic from router 7 is sourcing or coming from the IP address 169.255.0.1, which is the public IP address I have here. And it's going to this IXP, and this IXP now knows how to get to my public prefix because I've learned, or I've leaked the route to them, or I've sent the route to them. And because I've got this little NAT thing going on here, I've got internet breakout. So we've kind of got a functional IXP with a link between us, and this will be useful for some future content we're going to work with, because we'll add some more ISPs where they'll also be peering with the IXP, or we'll be peering directly with our ISPs, just to play around a lot more with the BGP. Okay, so now the other fun thing that I wanted to do, and I might increase this block again. I just want to move these devices a little bit, because what I'm going to do now is I'm actually going to add a firewall to our topology, because I know some people were wondering, okay, cool, from previous videos, if you span stuff like VRFs, how do you actually get out to the internet from the other VRFs? And I showed you some stuff, well, I showed people some stuff in the videos about VRF route leaking and how to get to the internet. But this is a much more common practice, is where we bring a firewall or another device into the mix, which is existing in both of the VRFs, and that can push the traffic to your actual internet side. So what we'll do is I want to bring in a 40 gate firewall into the mix, which is something we're going to have to do from scratch quickly. So I'm going to go into my Eve, and then what we're going to do is we need to upload an image, or let's do the first steps from the first stream I watched or created. We're going to go to EVE-NG, and then from EVE-NG we're going to figure out how do we import a 40 gate firewall. So I've already downloaded the software images. It is a trial license, and I know a lot of people watching are here because of the MiCritic, but multi-vendor is something you're going to have to learn, and being able to work on a firewall, it's pretty much, it's like routers. If you know how to work on a firewall, you can practically work on any other firewall. If you know Fortinet, I can promise you, you can go, even though the stuff might look different, you can work on a Palo Alto or a Checkpoint or Sonic Wall or all that other stuff, because policies and routing and all this stuff works pretty much the same. Okay, so let's go into our how-tos. Let's find a nice little FortiGate Fortinet images. Okay, perfect. So I've already downloaded the image, and the image you get from their website. So what we're gonna do is, I just don't know if I downloaded this as KVM. I don't think I downloaded it as KVM. Let's quickly see, can I make it work or not? Let's just try and make it work with what I have. So let's upload. Okay. Let's go into an SCP. Let's just first connect onto our Eve server. So I'll bring them an SCP over this side so you can see what I'm doing. So let's go into a new session. We want to connect to 192.168 74.128 root Eve. I've connected. Now what we want to do is, we actually just want to create a directory. So let's just do that from the command line quickly. Make their OPT unit lab add-on QEMU. Now we need to specify what we want to create. So let's just see FortiGate. We need to use Fortinet-FGT. Okay. Can't copy it like that. So let's just Fortinet-FGT dash. This is v6. And then I just need to confirm what the build is that I have. So I downloaded 2 different builds, because I know I've had issues with the newer version of FortiGate. So this is 1828. 18. Build 1828. Alright. So I've created a directory. So let's just go back to the WinSCP. Just refresh that, and then we actually go into there ourselves, OPT, unit lab, add-ons, QEMU, Fortinet. And now I just want to load this image in. So image is loading, and it's loaded. So what we'll do from here is, because it's definitely not what I've got here. So let's just rename that. So we're gonna do a MV. Oh, we first need to CD to that directory. Oh, sorry, this chair is being very uncomfortable now. OPT, unit lab, add-on, QEMU, 40. And let's move that image to virtua.qcow2. Even though this isn't the KVM image, I'm hoping this will work. If it doesn't work, I'll just have to get the KVM image. Let's just fix the permissions quickly. So OPT, unit lab, wrapper, UNL wrapper, -a, fix permissions. Alright, permissions are being fixed. Cool. So if we go to our Eve topology, let's just see if this works or not. There should be a node, Fortinet FortiGate. Just add one. We can't tweak anything here. Let's use a nice little firewall logo. So there's a C firewall. Let's use the blue one. And let's save that. So now we've got a nice little FortiGate firewall. Besides the FortiGate, I might actually just bring in a switch as well. So let's use another Cisco IOL. Let's just make this a switch. Even though this is really just going to be doing layer 2 for us. Save that. Now we've got a switch, and you can imagine this is all in the data center. So router 7 is in our data center, our firewall is in the data center, and our switch is in the data center. Well, a lot of your routers might be at the data center, or they could be at towers or something, you know. Alright, let's just connect up some of the devices. So I put Ep.03, the public IP on there, and I'll put it on E00, that's fine. And then from there on the switch, I'll connect to the firewall. That actually looks better, but I just need to move this loopback address quickly. Let's put the firewall there. Connect that. So port 1, that'll be our untrust port on the firewall. And E01 will be for the switch. Nice. Let's just quickly start up the devices. I really hope this FortiGate boots up. Let's see if I go into the CLI, does it do anything? It's actually booting up. That looks very promising. So while that boots up, let's jump into our switch, because remember we had the VLAN 99 that we spanned. Oh, the Cisco switch also takes some time. So let's just go into config T, interface. Can we do a range? Yes, we can. E00. How do we do the 2? I think it's just like that. -1. Port. Trunk. I'm actually not liking what I'm seeing on this Fortinet image. So switch port mode access, switch port access VLAN 99. It's gonna have to create the VLAN because we haven't created it yet, which is fine. So let's control Z that, write it, show VLAN 99, show VLAN. Okay, so let's just go config T, VLAN 99, name. Let's call that untrust. Let's write it. Okay, I'm pretty sure this FortiGate isn't going to start up. So just give me a sec. I just want to download a proper image. So we saw we needed the KVM from the documentation. So I'm just quickly pulling that down here, which is fine, which is awesome. It's good for us to run into issues like this so we can actually do something about it. Because networking is, it's a stormy ship. Everything is always rocking, and when the network works fine, everything's nice because nobody bothers you, but when there's issues, you know, everybody's there. 6.4. Let's get the latest version, 6.4.5. And Eve tells us we need to get the KVM, so we will get the KVM. So version 6, KVM. There's a KVM. I'm busy downloading it as we speak. There we go. It's busy downloading. It shouldn't take too long, I hope. Because now it's actually being a bit funny. I just hope the download doesn't impact the stream at all. Alright, let's just go back here. I'm just going to stop the FortiGate and log out of there. Oh, I don't actually want to log out there. I wonder if I try and open it up like this, will it open? Good. Okay, so let's delete the Fortinet here. And then while I wait for that download to finish, I want to show you some cool things that Eve added in the latest build. And that is the traffic graph. So for any new networks that you bring up. This is pretty cool feature. There's a graph here that you can just click on, and you can literally see what is happening traffic wise on your link. You can see it's brought up a nice graph here, and this graph will tell you how much traffic is flowing over this network on that interface. Very useful. We could do some pretty cool things. Again, this is an Eve Pro function. We can edit like the quality, and here I could just pump up the latency, make it a bit higher, which would be nice when we want to test some stuff like failover. But you'll see the graph will correlate like what is happening, what's going on. We've added some high latency, so let's maybe add a lot of packet loss, apply that. So now we have a very unstable link. Let's just jump onto router 6 and do a test. Admin blank. So if I ping 9.9.9.1, which should be directly over this Ether 1, let's see how much packet loss we're getting. Ooh, that doesn't look promising. Oh, this is one thing. This is actually why I don't like using this HTML5 console with MikroTik. You need to log in twice for some reason, else the router doesn't like respond to some things. I don't know why it does that, but it's a thing. Apparently it's still a thing. I'll just close there. Okay. Why am I not able to do anything on this router? Hello. There we go. Alright, so we're running our ping to 9.9.9.1, and we're getting an extreme amount of packet loss. That's actually more than what I'm expecting. Let's edit the quality again. There's one packet. I think something bugged out a bit there. Let's add this again as 00, apply that, save. There we go. That looks a lot better. But that's pretty neat about Eve, and that's why I love it, because you could do stuff like IPSLAs, or if you were labbing maybe something like SD-WAN and you want to test that type of IPSLA, if you want the links to switch over between a better path, then you could totally emulate that and see what the results are. Alright, my image has finished downloading apparently, so I'm going to close this. And then let's follow those prompts. Okay, we've already made a directory. So all that we need to do now is actually upload the image. I just need to delete the old one quickly. No. So we want to rm minus rf this virtua.qcard2. Alright, so we've removed that completely. Let's just refresh here. And then what I'm going to do is I'm just going to jump into my downloads folder. I'm not seeing the image here. I'm getting trolled. I'm actually getting trolled by my browser. Okay. Not happy with that. So we might just stop the firewall idea until we actually have the image. So I'm gonna rerun the download. I don't know why it failed now. So let's find the KVM image again. KVM. There you are. Please don't download just a Google Chrome thingy. That was really annoying. Okay. So we'll just emulate it with another router, just for the sake of keeping the stream going instead of, you know, causing issues. So I'll just add another MikroTik for consistency, but I am going to change this out with a FortiGate the moment it becomes available. And my topology just decided it's going to make a big window of the switch. Alright, so we've got a MikroTik here. Let's just call this... can I make brackets? Yeah, or yes, it's a firewall. So we call this a firewall. Let's get another firewall image. I mean, the MikroTik does have a firewall working on it, so that's not wrong. Nice blue firewall. Add it. There we go. Let's add that now on E01. And let's start this up so long. So we're starting this up. It's just another MikroTik router, nothing special. It's the beta version. And I'm not sure if you remember the last stream, but the beta version didn't play too nicely with some of the things with the version 6 stuff. Yeah, you could do that if you want. You could do that. So let's just add another node. Make this a fake firewall again. Just select the right version this time. Firewall. And is there anything else I want to add? Maybe just change this image again, make it a firewall. Save this. And now it's calling it module 16. Which kind of reminds, or node 16, okay. They call it firewall like that without the exclamation. Firewall, add it to our switch, E01. And let's start this puppy up. And this is again making a mega window here. Let's just admin blank. Okay, no, I don't want to see that stuff. My problem now is that Eve is, for whatever reason, there we go. But now the text is super small. So I've actually accomplished what I wanted to do with the graphing that I wanted to show people. So I'm just quickly going to log out here. We're logging back in, don't worry. I just want to go to the native console because I want people to actually see what's being typed in the CLI if we type anything. And the base, there we go. That should be a bit better. IP address print. So first things first, we just wanted to add the VLAN, which was the VLAN 99 interface, VLAN 99, or add on the interface we're going to put that on is our Ether 1, I think. Yes. And then on Ether 1, the VLAN ID will be 99. And the name, we can call this the untrust. And then we can add the IP address. And the address is 169.255.100. Let's make it .2 /24 on untrust. IP address print. So let's see, can I actually get to 255.100.1? And that is timing out at the moment, which it should not. I just want to make sure of something here. Do I still have router 7 open? I do. So let's just check. I've got my untrust VLAN on Ether3. VLAN ID is correct. Our address is correct. And it is on the right VLAN. Okay, so that is all good. So something's not happy from the switch layer. Oh, I know. I know what it is. So I set the mode as access for both of the ports that was running to my routers, which is actually wrong because we are tagging a VLAN. We're not just accessing it. So let's change that quickly. So config T interface range, and then it's E0 0 to 1 switch port mode trunk. All right, it's gonna get angry at me. So we just need to say switch port trunk encapsulation, and that should be .1q. And then we can do a switch port mode trunk, and then the switch port Actually, we're not going to add anything else. We can just leave it that, so it will allow all the VLANs. Let's just right name that. And let's just look at the config quickly, E00. Yeah, I'm happy with that. I'm fine with that. So let's quickly see. Actually, let's remove that access VLAN. Interface range. No switch port access VLAN. Right, name that. Now I should be able to actually get some form of breakout. Do I still have PuTTY open? Yes, I do on my firewall. Now I can ping my 169.255 100.1, which is perfect, which means I could use that as my default gateway. So let's just quickly add that. So let's go into the command line, just do it from there again. So IP route add destination 0000/0 gateway 169.255 100.1, and let's see if I ping out and if I source it from 169.255 100.2, I do get breakout. So we are actually able to provide breakout through an untrusted network. But this isn't what I wanted to show people. I've actually want to span some VRFs between router 7 and 6, and we want to then provide some form of internet connectivity for different things, for different customers. Because we might have something like the small network on the left hand side where our wireless links are running, and maybe I said this one on the left was fiber, but this is like our let's make that triple PoE later, but let's say this is our customers to just dial into the network to get internet breakouts. So we're probably just going to add them to their own little VRF as well. So let's do that by going into our router 6, and I'll do this from Winbox on router 6 or 7. I just want to connect onto the ROM on, and then let's get to router 6. And then from router 6, let's just close all our windows quickly. And what we're going to do first is we're going to just add a peer, and the peer is going to be router 7's loopback address. And this will essentially be for us to run VPN 4. And I might just enable L2 VPN from the get-go as well. Actually, let's just disable that. We'll enable that if we have that requirement. Our update source will be our loopback address, and then our peer, there should be peer to R7. Our instance will be the 65000, and our remote address will be the 9997. Our AS 65000. And we're not going to set any of these other values. We have set what we actually wanted to, so let's apply. And then we're going to set up a similar peer on router 7, and that I might just quickly do from the command line. Yes, I am from South Africa. Are you from South Africa, or where do you come from? Alright, admin blank. So we're going to go into our routing. We did add the AS here, which is great. So we can just do a routing BGP peer. Let's add a peer, and our name, let's just give it a name first, is peer to R6. Oh, hey. Hello. How are things there? Where are you from, the east or west coast? Because I'm sure is it like afternoon there now? Or maybe morning still. I do appreciate you tuning into the stream though. Really, thank you. So peer to R6. Our remote address will be 9.9.9.6, which is the loopback address of router 6. Our remote AS will be 65000. Our instance will be AS65000. Our address families, which is important. By default, it does add IP, but we want to make sure that we add the VPN v4 as well. That will be for the VRFs and spanning them across. And we want to set our update source, which is the LO0. And that should be it. So let's look routing BGP peer. If we print that, it did establish, which is fantastic for us. So we can run services through the BGP now. And what I would like to do is, let's just go into Winbox quickly and go to router 6's Winbox. And then from here, we're going to just create a VRF. Let's isolate our customers that we provided some services for already, which did have breakout, but they probably don't have any breakout right now. Let's test it actually. Let's see, does this CPE12, can this break out? Because when we ended the last stream, they could, and now they cannot. Print. Okay. So what we're gonna do is we will go back to router 6, and then from router 6, let's just first add a VRF. So let's call this routes, go into the VRF tab, hit the plus, our routing mark, let's call this customer, triple PoE customers, even though they're not connecting on triple PoE yet. Or better, let's just call them the wireless customers. Wireless customers. And then our interfaces for that will be the interfaces that will actually... So that is Ether 3. Would have been better if I deliver... Wait, no, I did deliver it via VLANs. Perfect, this is awesome. I'm really happy we had the foresight to actually add VLANs. So we can just add those VLANs to the routing mark. Let's add a route distinguisher for this. So here you see, it's very interesting. You could make it something like your IP address, colon your ASN if you wanted to, or you could make it ASN1, but we'll just keep it simple. We'll make this our very first route distinguisher, which is 1:1. And then we want to import some route targets, will be 1:1, and we want to export some route targets so that we could exchange routes via this BGP that we're doing. So let's apply that. And what we're going to do now is, but there I see my BGP peer to that customer just dropped as well. But I know why that is, and we'll fix that up in a second. So let's jump back to router 7. Actually, there's just more we can do on router 6. So let's just go into our BGP, go into our VRFs, add a VRF. Our instance will be the backbone, which is in the main routing table, but our routing mark will be for the wireless customers. And then what we could do is we could redistribute any static routes we do for them, any connected routes, or any other BGP routes. That should be good. Let's apply that. And then I'm going to jump to router 7, and this we can do on the command line. So first things first, we want to go IP route, we want to add a VRF, we want to add, we want to give it a name, or routing mark, sorry, which will be wireless customers. And I'm just going to do that for now. We still need to add some interfaces, but it's going to make sense what I'm doing in a bit. Oh, and I need to set my route distinguisher. Sorry, I forgot about that bit. So set route distinguisher 1:1, export 1:1, import 1:1. So IP route VRF print. Let's just see, that looks fine. So we can go routing, BGP, instance, VRF add our instance should be the AS65000, and our routing mark will be customer wireless customers. I'm just going to hit enter with that. Let's print where routing mark customer. Okay, so we have spanned the VRF across for our wireless customers, and we are learning their link addresses now over the MPLS via BGP, and they're in their own little VRF cloud, but they don't have any default route out now. So there's two things we need to do. One being we need to actually send out a default route to them, and then we need to give them a way to break out. So on router 7, even though there is like breakout and stuff from there, all that I'm going to do is I'm going to advertise those routes to them. So what we could do is, and this is why I wanted a VLAN to a firewall. I'm actually getting pretty annoyed at the firewall image. It's not downloading the way I want it to. Okay, in the next stream you'll see a bit of Fortinet stuff. This stream unfortunately not. Okay, but we've got our fake firewall, so we're fine. We've made a plan and we can make things work. So first things first, what I want you to imagine is on this fake firewall, we're gonna have a way for the VRFs to get to each other, because the untrust VRF will be on the firewall as well, but we will have a interface that will be inside the customer's VRF so that they could actually be able to get to the firewall as well. So let's just make a new VLAN for the customer's VRF, and that will be VLAN, let's make it 200 upwards will be for our customers. So VLAN 200 is what we're going to choose. So let me open up the firewall, and then we're going to go into our interface, VLAN. We're going to add a VLAN. Let's give it the name of, this could be the VRF wireless customers. The VLAN ID will be 200 now, and our interface is Ether1. This could have been on a separate interface as well, but we're trunking everything over Ether1 for now. And then what we could do is assign a private address between our router 7 and firewall on this interface that will be in the customer's VRF. So let's just duplicate this. Maybe make this a little bit smaller. I'll do it from here. Make that like 22. That looks good. Okay, so for this we want some more private IPs again. So I might use something in the 10 range still. So we're going to use 10 dot, let's say 254 for whatever reason, 10.254 dot 255 dot 0/30. Okay, I just need to resize this again, just to make sure everybody can see what I'm doing. So this will be on VLAN 200 now. So let's just make sure people understand that it's going to be on the VLAN. What size did we make this stuff? 24. It's a little bit too big. 22. That should be good. So VLAN 200 now has this address of 10.254.255.0.30. So let's add VLAN 200 on router 7 as well, and we can quickly do that on Winbox. Good old trusty Winbox, and I love Winbox. I don't like WebFig. I know some people use it. I know it's like a ugly version of Winbox, but I dislike it, and I know it puts off a lot of other people when they try and showcase MikroTik and they're using Winbox, and then people's like, what are you doing? IPv5, I'd have to check as well. I'd have to do some research, because I know it like evaporated into the air, into the ether. We got from IPv4 to IPv6. I have no clue what happened with v5. I know it was in development, but I think it was in development like when I was still a toddler or something, so I really couldn't tell you what happened with v5. Before I lose myself in my train of thought, let's just add that VLAN 200, and that is going on Ether 3 if I'm not mistaken. Yes, so this is now VRF wireless customers, and that is on Ether 1. I'm happy with that. So we've got a VLAN now for our wireless customers. Let's just quickly assign the IP addresses. So it was 10.255.254. Am I right? 10.254.255. Sorry, you see how easy it is to mix this up. Let's make router 7.1, and let's just add this a little bit bigger. Let's make it a /29 pool in case we want to add more routers or add stuff like VRRP in the future. We want to future-proof our networks. It's probably bad that I made a bunch of /30s here on my links, but it's because those are direct links that we connected to the router, so it didn't like go to switches or stuff. Okay, so we've got that. We'll assign it to our VRF wireless customers. And now on the BGP side of things, or on our IP routing for router 7, we just want to add that interface to our VRF. So VRF wireless customers. And what we could do now essentially is we could go into our routing, and from our routing we could go into our wireless customers, and we could add a default route to the firewall. So our gateway will be 10.254.255.2. That's the address I'll give to the firewall just now. Let's apply this. And with any luck, if we quickly just skedaddle to router 6, we'll... Wait, I've got router 6 open on Winbox as well. So let's just quickly open it up on command line here. I'm sorry if it looks like my desktop is so messy because I open so many different things, but it's just kind of how I work. It's how I find my way around everything. So if I do IP route print and I say where, and the routing mark is at wireless customers, I'm learning a default route to break out to the internet now. That is fantastic. It's still not going to work because, and this is how you ping from a VRF, you just select the routing table, because there is routing now set up for our default route to go to our firewall, but our firewall isn't pushing the traffic where it's supposed to be going. So this is why I actually wanted to showcase this on a firewall, because firewalls work with different zones and such, and you could essentially also have different VRFs on the firewalls, but typically what you'd see is there's the zones, there's an internet zone, and there's a VRF or customer zone, and you could have separate customer zones, and you could allow traffic from the customer zone to your untrust, and you could just NAT the traffic out, and that's how you could provide breakout from different VRFs through a firewall. And it doesn't have to be just like this firewall. It could be, that's why I love firewalls as well. You could have a HA cluster running where these two firewalls, exact copies of each other, they're copying their configs across the whole time, and if the one firewall should die, the other one just takes over automatically and everything just works. So cool. So cool. Anyways, let's just fix up our internet stuff quickly. So router 7 for the customer VRF, it pushes it to the firewall. So I need to check on the firewall. I think I haven't actually assigned the IP on the firewall, if I'm not mistaken. That's probably why things aren't working too nicely. So IP address, let's just add the address for 10.254.255.2/29 on our VRF wireless customers. And let's see, can I ping 10.254.255.1? That's timing out. I dislike timeouts. Is the IP address correct? Let's just verify both sides. So let's jump onto router 7. That's 6, that's 7. So 10.254.255.1/29. Okay, that's fine. 10.254.255.2 VRF or customer wireless. Just see if we're learning any MAC address back. No, we're not. So this is what we typically call a layer 2 issue. If we're not learning a MAC address back, we know there's either something with the link or a switch somewhere, or maybe a VLAN's not being spanned correctly. So let's just jump on the switch. I actually think the reason is I don't have VLAN 200 defined on the switch. Because if I do a show VLAN, you'll see 200 isn't defined. So let's just add this VLAN 200, and let's call this VRF. Yeah, let's call it wireless customers. Let's shorten this wireless right mem. And if I look at router 7 now, can I actually ping? Let's try again. I'm still not able to ping, which is annoying a little bit. Still not seeing any MAC address. Let's maybe delete that MAC address, and yeah, it's constantly trying to get there, but it's failing. Okay, show VLAN 200. So we've got VRF wireless customer. Show run int E00. So I'm trunking everything there. I'm trunking everything here. I'm just quickly going to enable Ramon on that firewall, so I could just get on there from Winbox quickly. Tool Ramon set enabled yes. And let's close the stuff and see what happens if I Winbox in there. Connect to Ramon. And we have MikroTik, which is the actual firewall. And let's just see, we have our VRF wireless customer. That looks good. .254.255.2. That looks good. So I'm actually a little perplexed right now why this isn't taking, but it might have I can think of a few reasons, and it might have to do just with like Eve or the Cisco image that I'm running for this switch. Let's quickly stop the switch, kill it, because we've got the VLAN on there. Come now, stop. And we've got the stuff configured on the routers where they need to be. Just going to add a new node. This will be a Cisco viral image. Very old image, but it will do just fine, and it will do what I want it to do. Let's add maybe 24 Ethernets. Save that. It's still got a router image, or router image. But that's just the image. It's just a photo. It's just an icon. It doesn't do anything. So GI00. Let's be consistent. GI00 went to router 7 on Ether 3. And then we had Ether 1 on the firewall come into GI01. And then the VLAN is still there for VLAN 200. So remember, I need to add VLAN 99 as well. And we just need to wait for this image, but it looks like it's loading up quite nicely. Not too slowly. I'm wondering, or I'm considering for the channel, if I maybe want to try and procure a MikroTik switch, because a lot of people seem to be interested in VLANs on MikroTik for some reason. And it'd be nice if I could show them on a physical MikroTik switch, even though you'll be running router OS on the switch. Just like what switching is about. But I expect a lot of people that's watching now aren't too bothered about switching. Can this load or not? I'm hoping this loads, else I'm wasting my time again. Let's just give it a minute. But that's the nice thing about Cisco, the boot times that are really short. No, I'm joking, obviously. So I'm sure if you worked with a Cisco or Juniper router or switch before, when you do that reload command, it can take a little bit of time for everything to come back up, and that's why I really like MikroTik as well. Like, it's so quick to boot up. But then again, there are limitations if you're working on a carrier network and you're comparing MikroTik to like Juniper, because even though MikroTik is amazing, there are things that a Juniper or a Cisco just does better on your core network. And that's something I hope changes with the new version, but I'm doubtful they'll bring, like, I brought it up in the previous stream, like IS. I would really love for MikroTik to bring that in. Okay, what is our little switch doing? Are you still just booting? Are you having a good time? Having a really good time? I don't think the switch is gonna boot up. I'm gonna cancel that. I'm just gonna kill this switch as well. So we're gonna emulate a switch as well. This feels like such a failure with this switch. I'll get some better switch images. Because all that we're gonna do now is we're gonna connect the firewall directly to the router, and we're gonna have those VLANs already on the ports. So Ether 1 to Ether 3. But I wanted to put the switch there as a typical example, because that is what you would find in your data center. Your firewalls in your router would probably connect onto a switch, and then they'd communicate to each other like that, instead of having a direct link like this. Because when you've got a direct link like this, things like the HA won't really work, and you can't really do VRP if it's a direct link coming in on the router. You want it to come in through a switch. Okay, so let's jump back onto our firewall. If I can find you, mister. Wasn't this my firewall? Let's just reconnect to the Roman. Find our neighbors, connect to Roman. And then from here we can go on to the firewall, which I'm not seeing yet. Okay, let's just jump in through the CLI, even though I'm pretty sure I've got a window open somewhere. So let's check IP address print. Can I ping 10.254.255.1 now? I still can't ping it. Interface VLAN print. That is Ether 1, and that is correct. Detail. Wireless customer, VLAN ID 200. And let's do the good old disconnect the link and just reconnect it. Because what I did notice as well, remember, I didn't see this firewall in my neighbors for some reason. So let's just check from router 7. And let me do you all a solid. Let me just close all those putty windows. And I can reconnect as needed. All right. Let's just first get on router 7, and from router 7 I just first want to see, am I picking that up in my neighbors? Router 3, router 5 and IXP. Interface VLAN print. So Ether 1 has... No, I'm so... Do you see how easy it is to make a terrible mistake? That first switch was working just fine. So if anybody can point out why this isn't working, if you can see what I'm seeing, then you know we can quickly fix it. Else I'll fix it in like 10 seconds. I just want to see if anybody has any clue why I wasn't learning, firstly, a MAC address, and why it's failing, why I'm not getting a neighbor and stuff back. Even though technically I should still see a neighbor on the interface. Okay, so what basically has happened, or what I failed at doing, is I've got router 7, and router 7 is connecting to the firewall on Ether 3. But if I look at my VLANs on router 7, and this is the VLAN that I created specifically for my VRF customers, which is VLAN 200, I've bound it to Ether 1. Now Ether 1 is going somewhere completely differently. It's going to router 3. So let's fix that by simply just changing the VLAN. So let's do a interface VLAN set, interface equal Ether 3 on 1. Okay. And it's still timing out, so I'm getting very frustrated now. Even though that is definitely an issue. Like, that shouldn't have been there. Interface VLAN friend. Okay. So what I quickly want to do is stop the firewall. Let's maybe disconnect this cable. Let's bring back another switch. Cisco IOL. Let's give it a few more ports. Maybe let's give it 4. It should be 16. Actually, let's give it 6. Let's call that switch. Layer 2. Yada yada. So there's our fake switch again, which I'm pretty sure was a good switch. I just made a mistake. And let's drag that into our firewall. So our E01 goes to Ether 1 on firewall, that's correct. Let's start them up again. And this is at least the nice thing about the Linux image for the IOL. It starts up real quickly. Enable. So config T, VLAN 99, name untrust, VLAN 200, name, VRF wireless cust. And then what we want to do is just quickly set those trunk ports. So interface range E0021. Switch port trunk encapsulation .1q. Switch port mode trunk. Write mem. Show MAC address. Show MAC address table. Let's quickly see if we can pick anything up. Router 7. IP neighbors. So now I'm seeing the Cisco in my neighbors, which is good. Can I ping across? Yes, now I can ping across. If I've given it the right IPs. So let's just make sure. Am I .1? I am .1. Man, it's taken way too long to get to this point. But now we've actually got our firewall that can talk to the customer VLAN, and it can talk to our actual untrust. And you could have had your untrust in its own VRF as well. It's not unheard of. Some people try to separate as much of the network as possible. You might have different peers or different transits, and you'll put them in their own little cloud so that they don't interfere with any of your other customer stuff. But it's fine what we're doing here. So now we've got an untrust network and we've got the client network, and both of these are now in the same VRF on this firewall. But again, if it was an actual firewall, we'd have had zones, and I could have probably explained things a little bit better. Okay, so from this router, do we have breakout? Yes, we do. So from the firewall, all that we could do is maybe IP, firewall, NAT, add. It will be a source-based NAT, source NAT, or chain is source NAT. Our out interface, equals, and that will be our untrust. And our action will be to source NAT. Actually, we could just masquerade it, that's fine. Wait, let's do source NAT. I know some people like to do this rather. And then to address is 169.255.0.2. So let's see, can I still ping 8.8.8.8? No, I can't. IP firewall NAT print. IP firewall NAT. Let's just remove 0. I'm just gonna add the masquerade quickly. IP firewall NAT add chain source out interface untrust action mask. Can I ping 8.8.8.8? Yes, I can. But now the question is, can my customers ping 8.8.8.8? Because my customers are technically getting into my network and they're in my VRF. I just want to see if I added some static routes here. Yes, I did. And I think I added NAT rules here as well. IP firewall NAT print. Yes, I did. So let's see, can I actually ping out? I'm failing to ping out at the moment. So let's just see, is there any specific reason for this? Tool, traceroute, 8.8.8. Source address 10.201.0.2. Because in theory, traffic from the CPE should be getting to router 6, and router 6 is in that VRF. So let's just jump onto router 6. That's the IXP, that is router 7, that's router 6. So from router 6, let's just see, are we learning routes in the wireless customer? Yes, we are. So let's see, can I actually ping out from this VRF? Customer wireless. So I've actually got breakout from the wireless customer. I think the reason is we don't have any routes to return the traffic from this firewall to router 7. So what we could do to make this work for our customers is on router 7. Let's just jump on Winbox. I just see we're doing so much NATs now, but this is why I want a firewall. So what we could essentially do is, because the traffic is originating from the 10.201.0.0 whatever IPs, and it's getting across the network. It goes to router 4, well, it's going through the MPLS, then it gets to router 7. Router 7 is pushing it to the firewall. And there is a way to get out, but the firewall doesn't know how to get back to those source IPs now. So I could add those source IPs into a list, but the easiest thing we need to do is just to masquerade the traffic out from router 7. So let's do the NAT. And what we could do is we could actually make a source address list. Let's call this wireless customers. So we'll use a source address list, and then from the source address list, what we'll do is say anything that's leaving VRF customers, we'll mask that. And then we can go into our IP firewall. We can go into our address list, just add one. Wireless customers, and then our addresses could be the link addresses, which is 10.201.0.0/30. Apply, copy. .4 and .8. Nope, .4 and .8. So now I have an interface list that says anything coming from these source IPs for our customers, our wireless customers. I want them to be natted out when going to our firewall. But man, I really wish I could spin up a firewall and actually give a very good example. But this should actually work now. Let's just jump back to the CPE and let's see, can we actually, the trace route is still failing, but we are pinging. So we are actually getting breakout. We just try and rerun the trace. All right, so there's a bunch of hoo-ha. So there's my actual Eve management network. And here is all of the other stuff. So these timeouts are probably just occurring because of the MPLS and the masking and stuff happening. So don't worry too much about that. But we have actually now given customers in a different VRF internet access, and it's not going to interfere with anybody. So that's pretty cool. I dig that. I'm happy with that. I'll take it. And we've done something fun as well. We've actually spanned a VRF across between router 6 and router 7. But let's say we had a different customer range, a different VRF. Instead of our wireless customers, it was some fiber customers. So what we could do is just add another node, make it another MikroTik, or MikroTik. I wonder what the actual good pronunciation is. We just say MikroTik in our country. So let's call this CPE 13. We'll change the image, add 12 ports, and let's save this. So we've got one more router. The router is going to come into our little access switch, but instead of this being on the wireless network, it will be a fiber customer. And I've run out of ports. So let's just quickly stop the switch, and we're going to add another NIC to it. Just unscrew it quickly. Got the ports open, and we're just going to slide in this additional NIC. So 2 NICs now. Okay, so that's an interesting prompt from Eve. Let's just quickly do what Eve is telling us. Delete all of the connections, but I'm sure this is just so that it can actually not spaz out when I add another NIC. So I might add a few more NICs now, to be honest. Let's add 4 of them, or 6 of them. And we can just connect all the stuff. But now I don't know where I connected what, so I'm failing. Let's just add Ep.03 to E00. I'm pretty sure that would have been the uplink to my core network. And then I wonder, let's just go off of the name. So let's say E01 is Ether1, E02 is there. And the reason I'm doing that is just because the CPE names, because I know I would have probably added them in different ports. Cool. So we've got our different ports there. So let's bring this sucker in. So E01 going to Ether1. And that is on my fiber network. We're also just going to assign a VLAN for that quickly. So router 6. This is on Ether3. Let's just copy this quickly. Let's call this 10033. And then our VLAN ID can be 10033. Let's call this CPE 1 fiber 1. Apply that. And we just need to boot up the switch quickly, boot up the router. Let's assign an IP address. But what I'd like to do is, or what I tend to do is, on my fiber or wireless links or whatever, the prefixes are not just continuations, because you'd like to know this pool of IPs belongs to your fiber, this pool of IPs belong to your wireless, whatever. So we might make it, let's make it 210. And then 00/30 for our customer. And it is CPE 13, admin blank, no. So all we're gonna do is system interface, system identity, set name. And our name will be CPE 13. Tool, ROM on, set enabled, yes, because I like that. What we can do is we'll deliver the services untagged to the CPE. So IP address, add address equals 10.210.02/30. Interface is Ether1. And then, of course, we just want to add a quick default route, IP route, add destination 00000/0. Gateway is 10.210.01, which will be the IP address of router 6. And let's just also add the natural IP firewall NAT add. Chain source out interface equals Ether1, and our action is to mask. Sorry, my face might be hiding that. Cool. So now we are masquerading the traffic. We just need to do the setup on router 6. But I'm doing this now so that I can span a separate VRF and also deliver traffic. Hey Bongani, haven't spoken to you in a while. So here we go. On router 6, we're going to add our IP address, or we want to add our IP address. I've got it on Winbox. Why am I going onto the command line? So let's go Winbox, IP address, add the address, and our address will be 10.210.01/30, and the interface is the fiber 1. Apply that. So let's just add that VLAN on the switch quickly. So enable show VLANs, and we can see what we've got here. So what we're going to do is config t interface VLAN, we don't want to add interface, sorry. We're just going to add VLAN 1033. Description, or let's give it a name of CPE 13. Let's Control Z, write that. And then what we want to do is config T int E10 switchport mode access switchport access VLAN, and that is 1033. We can write mem, because I do have a trunk running to router 6, so I don't necessarily need to tag anything now, unless I was specifically accepting or rejecting certain VLANs. So let's just see, can we get across? So from router 6, I might quickly see, can I ping 10.210.0.1.2? I'm not able to ping .2. Let me just make sure I've set everything correctly. I've done that. So that is E10, which is fine. Let's jump onto the CPE. IP address print. So Ether1, I have assigned the right IP, so 10.210.0.1. Why can I not ping? IP ARP print. I'm probably not learning a MAC address again, which tells me it is layer 2. So I'm probably messing something up on the switch, but this time I'm not going to delete the switch. We're going to troubleshoot and see what's not happy. So jump on the switch. Show VLAN. So 1033, that's correct. For ET10, and then I just want to see show run int for E00. Okay, that's why it's not working. 01. Man. I've connected the stuff a bit wrong. So let's connect it correctly from the switch's perspective now. Let's see which VLANs are actually going where. So it looks like E01 is actually the trunk for router 6. So let's add that. E01 is the trunk to router 6. And then we can look at our VLANs. So 00 is for CPE10. That's a trunk for CPE11. But that's then ETH2 or ET2 or 02, sorry. And last but not least, our CPE12. So everything is now connected perfectly again. Amazing. Let's do this ping. Why am I trying to ping from there? It's never going to work unless I add the VLAN interface on there. So router 6, there you are. Yay, we've got liftoff. Finally, we can get to our fiber customer. So our fiber customer, what we want to do is now again span a different VRF for them, because this is now going to be a VRF for our fiber customer. So let's just add a VRF, call this our fiber customers. Our interfaces will now be the 1033 CPE1 for fiber 1, and the route distinguisher, very important, needs to be different. Can't use 1.1 because you're going to cause issues for yourself, so we can make it 1.2. And I'm going to make that the import and export route targets as well, and I'll apply it. And since we've already got the BGP running and everything's working amazingly with our network, we could go into our VRFs, and then it's just as simple as selecting the instance, selecting the routing mark, and we can tell it what we want to redistribute. Apply that. And now we just need to do the same on router 7 again. So router 7, hello, how are you? And then we go into our VRFs, add a VRF, same AS, say, wait, I haven't added my actual VRF yet, so IP routes, VRF, fiber customers, VRF. We don't have an interface for it yet. We'll fix one up just now. Let's just add the route distinguishers along. 1, 2, 1, 2, 1, 2. Apply that. Now we can add the BGP VRFs. And we've got our fiber customers, and we can just redistribute our static routes because I'm going to send out a static route for the default route. So let's look at our IP routes and let's see. My fiber customers, am I learning stuff? Yes, I'm learning the link address for my fiber link, which is the /30 between the CPE and my core network. Awesome. So we're actually making some good headway. So now what we want to do is add another VRF, not VRF, another VLAN that's going to be put in our fiber customers VRF. And we could make that VLAN 201 now. We could call this VRF fiber customers. Tag it on Ep.03 as well. Apply that. Let's add our address. And this needs to be a separate address as well, but for this we might just use continuation addresses. So we use 10.254.255.0/29 for the previous, so we can just make this .9/29 for our VRF fiber customers. Apply it. So now we have an address on that VLAN. We just need to quickly make sure that the switch has that VLAN configured. Enable, show VLAN. We just want to config T. And then we want to add VLAN 201. And that is it. We can just give it a name if we want to be nice. So VRF fiber cust. Write that. And let's jump onto our firewall, which I've got here somewhere, I think. Else, let's just do that on the command line quickly. So we will do IP address. First, actually, the VLAN interface. VLAN add. VLAN ID 201. Name VRF. Fiber customers. And then the interface, which is Ether1. Now we can add our IP address. Our address is 10.254.255.10/29 on the VRF fiber customers. Oh, just quickly changed or restarted the music. It's doing that. Are you still watching? Which we are, I hope. Okay. So can I ping 10.254.255.9? I can. So this is already going way better than before. Now what we want to do is on router 7, let's just advertise that default route out. So we just need to add a default route as well. So IP routes. If we look at the fiber customers, their VRF just has a way to get to the link addresses. So let's add our gateway out as, oh, we haven't even added the interface yet because that's why it's not picking up there. So let's just add that VLAN to that VRF quickly. So VRF fiber customers, apply that. Now we've got a directly connected route, so we can just add our default route to say, to get to the internet, go to 10.254.255.9, which is the fiber customers VRF on the firewall, so that the firewall can now give some internet access. Cool. So I'm actually quite curious on router 6. what are we learning? So if we go into our routes and we go into the routing table for the fiber customers, what are we learning? We're not learning a default route yet. So that's strange. That I don't like. Let's just check from router 7. Are we... Okay, so router 7 isn't happy about something. 10. Oh, I used the wrong address. So 10.254.255.10 is the remote side IP. So if I go to router 6 now, we are getting a default route out. Awesome. Let's see if I ping out. Routing table, fiber. I can ping out using the fiber customers as well to Google. Let's just see if the CPE is actually getting internet access. Ping 8.8.8.8. So the CPE is not getting internet access, but again, this is because the firewall is getting the source as this link IP for the fiber, and it doesn't know what to do with it. So let's just add that in our access list again. So let's go to the Roman, connect to the firewall. I don't think I actually specified the list on here. I think I actually specified that on router 7. So let's do that for router 7 again. So let's jump on router 7. Let's look at our IP firewall. And then we had a address list for wireless customers. So we can add a similar one for our fiber customers. And then the link address is 10.2.10.00/30. Apply, and then we can go into our NAT rules. We could actually just copy this NAT rule, and we could just go to the advanced tab, and instead of using the wireless customers pool, we use the fiber customers pool. We can apply that, and if I go back to the CPE, let's test and see if I actually get some breakout now. I feel like it's still going to fail. Alright, so let's quickly see why is it failing. So traffic is, I'm not even seeing that it's being masqueraded at the moment. So let's just check our routes. Routes look good. Can I actually ping 10.2.10.0.2 from fiber? I can, so that is not the issue. Let's just look at our firewall, make sure the masquerade is fine. Oh, I'm really silly. We copied the rule, and you see how easy it is to make a mistake when you just copy stuff. We're not actually natting it out of the right interface. So our out interface is for our fiber customers. Our source address list is for the fiber customers. So if I check now, I'm pretty confident I've got internet breakout. So now we've provided internet breakout for 2 separate VRFs running 2 separate route distinguishers by having something in the middle of the network, namely a firewall, to bring the traffic into a centralized point where all of your breakout is happening as well. So that is pretty cool. That's pretty fun. I'm happy with that. I'm going to close all the Wimbox sessions again, and I might close the Putty sessions. Ooh, they're piling up so quickly. And it's nothing you guys are doing, it's me just, I don't want to say being lazy, it's just I'm so used to having all the boxes open and just troubleshooting from there. Let's just close. Close all this stuff, make it look a bit neater. Ah, that's pretty cool. So we've started the stream out, we created a little IXP, and we now are spanning VRFs across our BGP network and supplying internet access to VRFs. I love it. I'm very happy with that. Let's see if we can span maybe some other services. I don't know if you guys want me to show you how to do VPLS again. It is a recent thing I did. There's a couple of ways you could do VPLS. You could do it with direct VPLS, Or you could do the BGP signaling, which works exactly like what I just did with the VRFs. But I'm not sure it would serve much of a purpose just now to add VPLS. I feel like it would be coming from nowhere. So we'll definitely do it, just not in this stream. In another upcoming stream, we'll definitely do it. Let's maybe add some extra headers here just so that people understand this is ISP1. Not just people, for myself when we do the next stream. So that I don't get confused, because there's a lot of stuff happening. This is ISP1. Hello, ISP1. Nice. And now from ISP1, let's maybe create another much smaller ISP. They're not going to have as many routers or routers, because we're not going to do cool stuff like traffic engineering or all of the in-depth things we're doing here. We're just going to use them and abuse them a little bit. So let's just add another node. Let's maybe make it just like 2 routers, very small, nothing too intense. Add them 2 MikroTik routers, and then the point is there will just be these 2 MikroTiks connecting to each other. Actually, on 19 I want it on port 2, and 20 I want it on port 1. Yes, please. Yeah, we could definitely do that. I think it's similar to a question you asked me, so we could. If time permits. I still have a lot of energy, and I can keep the stream running if you want to see. Sure. So let's just add another block. Maybe zoom out a little bit. You can put them here. So then these MikroTiks will connect just to each other, and the MikroTik 19 will connect to the IXP on Ether 1. And MikroTik 19 will have a similar type of setup as router 7. It will also just be peering with the IXP. They'll have their own AS number, and they'll have their own IPs to get to stuff. I wonder, can I make this look a little bit better? Let's just try and edit the style, change this to maybe flowchart. That midpoint is fine. Oof. That's not doing what I wanted to. I don't want to dash it. No. No. I might just move the AS so it looks a bit better. Let's cancel that. Keep it a straight line. Alright. So we're going to create another AS here. And this AS will now be for ISP2, our competitor. They're also selling wireless services, and they're selling them cheaper than us, and we're really angry at them. But we don't tell them, because we actually have friends working at that ISP, and we think our friends are amazing, and we love working with them. So let's keep working with them. Let's just say they are going to peer with this IXP, and maybe later on we'll peer with them directly, and we could do some other cool stuff. But let's do the IXP bit. So let's just duplicate this IP, and it might be extremely small on the stream. I apologize for that. Let me just zoom in a lot. So the ISP2 will also have their own little link address to the IXP, and theirs might be .1.0/30. And similarly, they might have the .1 address on the interface going to Ether3 from the IXP, and then .2 on their MikroTik. I know it's funny, but how many friends and colleagues do you guys have working for, let's say, a competitor? I mean, for me, I have so many friends in the networking field, and it's awesome. Like when we get to talk and discuss networking concepts, and it's really fun. But it's so weird because they're kind of I don't want to say working for the competition, but you know, you're not in the same company yet. You guys are always like talking about stuff, so it's really cool. That's what I also like about networking. Like, people aren't really some people are. I'm actually now lying. There's a lot of people that I don't know if it's for job security, but they hold on to their knowledge like it's gold. They don't want to share how they did this or how the solution works or anything. It's just like I personally, I'm not like that. I love sharing the knowledge, but I know there are people that's like, no, I'm not going to show you how I did this because it's magic. And if you figure out my magic, then I might lose my job. And I don't know why people have that mentality. We should all grow and, you know, get better. Okay, I'm jumping off topic now. So let's get onto the IXP quickly just to configure this link and their stuff. So Winbox, look at our neighbors. We can connect directly to the IXP. And for them, we just quickly want to set an IP address on Ether3, which is 169.255.1.1/30 on Ether3. Let's apply that. And then we just want to go into our routing BGP. We've already got an instance defined, so we can just add the peer. So the peer will be to peer to ISP2. Our instance is 65100. Our address will be 169.255.1.2. Remote AS. I still need to decide on what I want to do there, so let's just make that 65200. 65200. And let's send them a default route out as well, because we are doing that for ISP1, which is my ISP. It's my ISP. It's the ISP I work for. Okay, and let's quickly jump onto MikroTik 19. We can do this on the CLI just to be quick. So admin blank, no IP address, add address 169.255.1.2/30, and that's on Ether1. Routing BGP, we want to add an instance. The name will be instance add. Name will be AS65200. Our router ID, I'll make that now 169.255.1.2, and we will, let me see if there's anything else I want to add. I don't want to redistribute any stuff. So AS, oh, we haven't specified the actual AS yet. So AS is 65200. Cool. So we have an ASN now. So let's go routing BGP peer add destination, or not destination, name peer to IXP. Our remote address is 169.255.1.1. Our remote AS is 65100. And our instance is AS 65200. Add that, routing BGP peer print. Our peer has established. So what we can do is routing BGP peer add, no, not peer, network. Let's just add a network for them as well. And their network might be .200. Let's do that. Duplicate. So this is their public address block that they bought from their region, which they wouldn't really have, but it's fine. And let's just add the network as network equals 169.255.200.0/24 synchronize no. And let's just add that address somewhere. So I'll just slap that on Ether2. So IP address, add address 169.255.200.1/24 on Ether2. Cool. So I'm almost sure if I do a ping 8888, I'm getting breakout, but I'm getting breakout from this link address. If I source it from my 169.255.200.1, I still get breakout, but I actually think I added a NAT rule. Let's see, IP firewall NAT print. No. All right. Oh, but it's BGP, man. It's BGP. That magnificent beast. Connect onto the IXP, and we'll see if I go into my routes. I am learning both provider routes. Okay, so now we have two provider routes. And let's say this is a separate ISP. And this ISP, they've got their own customers. But we've simplified the network. They might have like a lot more routers and switches and stuff. But let's duplicate this cloud. And that's typically what we would see in a diagram anyways. So this is there's their MPLS, and it's gone super small because they've got a small MPLS and we've got a nice big MPLS. 48, that looks good. Let's just refresh the topology. All right, very nice. Now we've got an ISP2 and we've got ISP1. Let's say, yeah, that should be their edge. We're gonna have to just create another router. So let's just do this quickly. IP admin blank, no, IP address, add address equals 169.255.200.2/24 interface ether1, and then IP firewall NAT add. Actually, we don't need to add NAT, I think. IP route add destination 0000/0. Our gateway will be 169.255.200.1. And if I ping out, I've got internet access. Amazing stuff. So what we want to actually do is add a CP on the ISP2. This is just another nice little MikroTik. ISP2 CPE1, let's call it that. Make it router. Make sure we select the right version. Give it 12 Ethernet ports. And this will now be a CPE for this competition. Then it will connect to their router. So Ether1 from the CPE to Ether2 on their MikroTik. So I don't want to get too involved with their IP address scheme, but they could also have the same link addresses as us, because that is in their network. It's a private range. They can have the same IPs if they want. So let's also make 10.2.10.00/30 between the CPE and their core or their provider edge. So let's jump onto the MikroTik 20. I think I'm still on it on PuTTY. No, that's MikroTik 19. So let's just jump onto 20. So on MikroTik 20, all that I really want to do is I want to do an IP address add. I might actually have to NAT stuff out. Let's just fix it with some static routes. So IP address add address equals 10. What is that address? 10 to 10 0.1/30 on ether 2. And what I want to do is just on our router 19, which is their ASBR, I just want to add a route back for the link address so that my NATing actually works. So IP address or IP route add destination 10 to 10 00/30. Gateway is going to be our 169.255.2.0.2. Let's quickly see, can I ping 10 to 10.0.1? Yes. All right, starting to shape up a little bit here. So on our CPE now, admin blank, no, IP address add address equals 10 to 10.0.2/30 on ether 1. And then I'm going to add a natural IP firewall NAT add. Chain is source, out interface is ether 1. There we go, and our action is mask. Cool. So if I ping 8.8.8.8, no route to host because I didn't add a route IP route. So let's just add a route quickly. IP route add. Destination is 0.0.0.0/0 and our gateway is 10 to 10.0.1. Let's see, can we ping out now? Timing out at the moment. Not a good sign. Ten to 10. Oh, not 2. 0.1. Okay, so we know we can get to our next hop and the traffic should be routing to router 20. So let's just take a look in there, have a gander, see what's happening. IP route print. Oh, before the stream. Okay, it's looping, great. Okay, so I've got a directly connected route. Okay, let's just check from MikroTik 19 quickly. So I can ping IP firewall. Oh, I'm being so silly now. So what we want to do is just add a chain out. So IP firewall NAT add. Our chain is a source. Our out interface equals ether 1. Action is mask. But we can also just specify a source address. And that could be 10 to 10.0.0/30. Because when I'm breaking out from these two routers in ISP2, it's all coming, or it's going out over the public ranges that the IXP is learning. But I wasn't natting anything out for the 210, so the IXP wouldn't know what to do with that traffic. Alright, so now it's being natted out. So everything should actually work. So let's go to our CPE. Can we ping now? Yes. IP DNS set server 8888 ping www.google.com. Nice, we've got internet access. So with that said, that means we have two CPEs. Well, we have a bunch of CPEs for ISP1, but we have some separate CPEs. Yes, hello. Yes, I've had a great day. Thanks for also joining as a member on YouTube. Appreciate it. Okay, so we've got the CPE1 and we've got, let's say, CPE13. We're going to build the EOIP tunnels over. Now, EOIP works very similarly as VPLS, but just to make sure that people are aware, it is a GRE tunnel actually. It's just a fancy name for GRE. So it's MikroTik proprietary, the EOIP tunnel, but it makes use of GRE, so you are adding some overhead to your network when you work with EOIP, and you might have some issues if there's MTU. So I might simulate that or emulate it just now, but let's set up EOIP quickly. So on CPE 13, I just want to see, have I enabled ROM tool ROM print? Yes. Let's just enable on CPE1 for ISP2 as well. So tool ROM set enable, yes, set system set. Actually, this I might do from the command line on the CPE. Okay, so let's just jump back into the theory of EOIP. So our main purpose with EOIP is in order to span layer 2 between two different sites. That means we'll be able to send VLANs over this EOIP bridge that we've created, and that hosts could essentially be in the same broadcast domain. They could be in the same IP range in order to communicate through an EOIP tunnel, and it has a lot of uses. One of the big use cases I had was a customer I had. They had a point-to-point link to a different office, but they wanted this office to have machines and phones and stuff that was on the same VLAN and the same IP ranges as at their main office where the point-to-point terminated at. And EOIP was actually very useful for achieving this, because I didn't have, because it's their point-to-point link. It's not like mine. Even though I've configured the point-to-point link for them, it's still, I don't have any provider equipment there. I'm not running a VPLS network, so this allows me to do something similar to a provider network, but over the point-to-point link, or essentially over internet if you need to. So let's just emulate that by connecting to router 2, connect to the ROM. Let's get onto that CPE 13. And then on the CPE 13, but it's been a while since I've worked with EOIP, so forgive me if I'm a little bit rusty, but we'll fix it and we'll figure out real soon. So we'll just go to the EOIP tunnel, and then from the tunnel we can create a tunnel. I'll just leave the name as is, EOIP-tunnel 1. This MAC address will essentially be like the port, because the EOIP tunnel essentially creates a fake or a virtual switch port in order to switch traffic, and this would be the MAC address of that switch port. So just be careful of this MAC address, because sometimes people just create tunnels and they actually have the same MAC addresses on both sides, and that's actually causing issues. It happens rarely, but it can happen. Okay, so with EOIP, important is our remote address. Ooh, what's our remote address going to be? Because we need to be able to connect to something at that CPE now. So if we want to connect to that CPE, it needs to actually have a public IP address associated with it. So what I think we could do to make that work is we could NAT a public IP down to both CPEs. We'll fix that up now. But let's just say 169.255.200.3 will be the IP address for the one side. And the tunnel ID, this is very important as well. This needs to match on both ends when creating an EOIP tunnel. So I might make this 50. You can do IPsec as well, but we're not going to add that. It's just going to add some more overhead on something that's already a lot of overhead. And we can just apply that as is. Next step that we want to do is we just want to add interface, or we want to add a bridge. And this bridge we're going to call your EOIP bridge. And this is actually the main doodad. I think the block's already advertised, but I'll show you now in a seckie. So we've got an EOIP bridge we're going to add. I'm just going to disable the STP for the protocol mode. I don't want to run STP. We won't do any of that. So we could just apply that. So this bridge is actually where your MTU and stuff comes in. Now, I've seen this cause the biggest headaches for people running EOIP. Because with the added overhead, if the MTU is too small, you're going to get packets that's like dropping and things aren't working the way it should. But we'll figure it out and fix it just now. But we've added a bridge, and then with the bridge what we want to add is we want to add our ports. So the first port is the EOIP tunnel, which we added. So let's put it on the same bridge. And we want to add the actual port on our CPE that might be on the LAN somewhere. So let's say here was another node, it's a virtual PC, and that's connecting on Ether 2 maybe. So on our CPE, let's just add an address for 192.168. Let's make it 88.2/24. Let's assign that to, let's actually assign that to our interface. Though we could assign it to the bridge as well. So Ether 2. Okay, next step. Let's figure out on CPE 1 for ISP 2. I'm just wondering if there's a smarter way I could do with the public IP addresses. Because either I'm going to NAT them down to the customers, or I could break up the /24 into smaller subnets and just assign that between the routers. And that might actually be the smarter play. Huh. Because at the end of the day, it's just there has to be a public IP address that's getting to the actual CPE. Because they are in two different blocks and they need to be able to communicate. So let's do that. What I might do is I might advertise some additional ranges quickly. So on router 7, let's do a routing BGP network add. Network equals, let's make it 101, 169, what was it, 200, no, 255, 255, 101.0, /24, synchronize, no. Let's just add that on our route filter quickly, so routing filter, print. Routing filter add chain IXP-out. Our prefix is 169.255.101.0/24. Our action is accept, and we can set the BGP mid to 1000 as well. let's just quickly, because what I'm gonna do is this new range, because I don't want to fiddle around and cut the subnets now, because it's gonna take too long. I'll have a look at your question just now. Quick question. I'm trying to add 2 ISPs to a MikroTik router. So that is a fairly common thing to do. What is your goals? Do you want the MikroTik to fail over between the 2 different ISPs? Are you looking to load balance? What do you want to do with the 2 different ISPs? Let's just say that's there, 201. Alright, so if it's PCC, you're probably looking at doing load balancing with the packet filtering. Not packet filtering, with the queue system. So that's something else we can investigate. I'm just not sure if I'm going to get to it now or tonight. I want to sort out this EOIP thingy first, but I could potentially make a tutorial video on the channel on how to do load balancing or actual like failover between 2 ISPs. I know it is a thing people ask for a lot, so we could definitely do that. We could definitely make a plan. Okay, so I'm advertising that stuff there. So on this ISP2 network, this is very straightforward, because all I'm going to do is I'm going to route traffic from MikroTik 19 . So I'm pretty sure multi-homing is almost a requirement these days if you are peering at an exchange point, or if you are like just peering in general. So I like it, I'm for it, I'm happy with homing, multi-homing. So MikroTik 19, I just want to route this new range that we spun up to the MikroTik 20 quickly. IP route at destination 169.255.201.0/24. Our gateway will be 169.255.200.2. Alright, Bogdan, that's something that I'll need to lab and see how we can set that up. But you can do anything, like what you're describing, it can be done. We just need to see how. Okay, so what I want to do now is this link address between these 2 devices, we're actually going to change now to 169.255.201.0/30. So I can now add an IP address. Let's just remove the old IP address, remove 0, IP address add address equals 169.255.201.2/30. interface is ether1, and we just need to make sure we have that IP on MikroTik 20. Print IP address at address 169.255.201.2 1/30 on interface Ether2, I'm sure. Cool. IP address print. Let's just delete the other old address. IP address remove 1. Let's just quickly see, can we ping out as 169.255.201.1? Can't ping out yet. I just want to see on the IXP, am I actually learning that range quickly? If I'm not learning that range. So what I could do in that event is on my MikroTik 19, I just want to see if I'm actually advertising that route quickly. Routing, BGP, network print. So I haven't added the network there yet. So we're just adding 169.255.201.0/24 sync no. Let's go to the IXP. I'm learning that range now. So in theory, MikroTik 20 has internet breakout now. Fantastic. And that should by proxy mean that MikroTik or CP1 should be able to break out if we source traffic from 169.255.201.2. Print IP route remove 0, IP route add, destination address gateway is .1, and let's try that again. Alright, so on ISP2 side, our customer has breakout now, and they've got a public IP address where they're breaking out from. And we want to do something similar for CPE13. So CPE13 is a little bit of a harder nut to crack, because what we need to do is we need to send that range to the firewall, and then the firewall needs to inject it into that VRF, and then from the VRF we'll configure the range between router 6 and CPE13. So let's quickly do that. Let's duplicate this. Let's delete that old IP. Let's make this 169.255.101.0/30. And what we want to do now is IP address print, IP address remove 0, IP address add address, and that is 169.255.101.2/30 on Ether1. And then what we want to do is on router 6, I'm not sure if I still have that open somewhere. No. But let's winbox to that. We'll connect to the ROM, find router 6. And then what we can do is go into our IP addresses, find the IP that was on this VLAN, and then we can just quickly update it to 169.255.101.1/30. Apply that. And now we need to go onto the firewall. So many steps just to get the EOIP to work. But there's many things we could do to get it to work. We could have added some naturals, but this would be the quickest and best fix that I can think of right now at the top of my head. So let's go into our we're in the firewall. So what we want to do is we want to add a route. Remember, there's no VRFs on the firewall. This is all just done through here. So we could add a route to say anything for 169.255.101.0/30. That gateway will be the IP address of the hop in the VRF. So 10.254.255.9. I think .10 is the firewall. So we apply this. And let's quickly see from this firewall, can I reach 169.255.101.1? It's pretty good. It's very good actually for us. But there's stuff on router 7 we still need to do because the IXP isn't aware of the range yet. So let's connect to another Ramon session for router 7. And then two things that needs to happen. First thing, we want to add a static route for this new public range. And that we can add on fiber customers. Let's see. No, it's already learning that range. Oh, okay. So what we want to do is on the main routing table, because this is where our untrust to the IXP is coming in. We want to add a route for that range, 169.255.101.0/24. And then our gateway will be 169.255.100.2, which I believe is the firewall's IP. Perfect. Now we need to add the BGP network, which we've already done. Let's remove that 8888. And let's quickly see if I go to the IXP, which I know I've got some sessions open to. Am I learning that route? I'm not learning that route yet, but I've got a suspicion why. So let's check on router 7. Do I have routing filters? I do, but they're not in order. So let's just shift that one up. And all that we need to do is let's actually check if it's learning it now. Still not. So we might just have to disable, re-enable, because that's actually like a little bug on MikroTik that few people are aware of. Sometimes the route filters, you need to disable them and re-enable them when you reorder this stuff. Alright, so the IXP is now learning those ranges as well. Let's just see from the IXP, can I ping 169.255.101.1? I can I ping .2? No, I cannot, but it's probably because .2 doesn't have a default route out yet. So let me see, do I have that CPE somewhere? Yes. So let's just check our routing, because we've removed that other address. So the gateway we can just update to 169.255.101.1. Apply that. Let's see, can I get to .2 now? I can. Awesome. So much done just to span some public IPs to our two CPEs. But now we can actually form those tunnels. So on CPE 13, let's just check our tunnel stuff. I mean, all of this should already be fine. We want to go on to the CPE 1. Let's just see what have I done regarding EOIP. I don't think I've done anything yet. Interface EOIP print. Interface EOIP add. Name. Well, we don't need to add the name. Important bits that we want to add. And this is nice on MikroTik, is it will basically highlight like required fields. So our remote address will be 169.255.101.2. Our tunnel ID, oh, it's asking us that, is 50. We hit enter. So if I do an interface EOIP print, I can see the MAC address on that virtual interface and all of the other details. Nice. Let's quickly do an interface bridge add name EOIP_bridge. Let's do a interface bridge port add, and then the interface should be the EOIP that was added, and the bridge is EOIP bridge. And let's say Ether2 is also going to like the LAN network. So Ether2 bridge is EOIP bridge. Cool. Let's add an address. I just want to see, what did I add on CPE13? 192.168.88.2. So let's just copy that. Add it here, make it .3 on the interface. We could still keep it Ether2. And let's also just add a little VPC. Ether0 to Ether2, that looks fine. So we're starting this up. And let's see what's happening. I just want to see on CP13. Looks like the EIP is actually up. Let's look at our tunnel. I mean, the tunnel is receiving some stuff. I still need to add the port here. So that is Ether2 on the EIP bridge. Okay, cool. So first things first, can I ping 192.168.88.2? I can. Can I ping .3? I cannot ping .3. So what I want to do is I'm going to do a little bit of a cheat. I'm going to add a management network to the CPE1 for ISP1 quickly, just so I can winbox on there very quickly. Also, I'm gonna do a bunch of weird things, which won't be nice. So let's just look at our neighbors. I should see there's the MikroTik. Let me connect. And let's put these guys side by side, because EIP is very symmetrical with the configurations. So there's side 1. And there's side 2. Maybe just make this a little bit. There we go. Alright, nice. Now we can actually go back into our interfaces, go into our EIP tunnels first. Interfaces, EIP tunnel. Okay, so what I suspect is I might be having issues because I've bound the IP to the actual interface instead of the bridge, so let's just move that quickly. And let's just see, can I actually get across ping 192.168.88.2? Still can't get across. It is running, so this looks normal to me so far. Interface, EIP1. I think I made a mistake with the remote address, because that doesn't look good. That doesn't look good at all. 201.2. Okay, that's back up. That's back up. Let's go to see now. Can I get to .2? Yes, I can. Houston, we have liftoff. I'm going to move the IP address back to the Ethernet port though. I can leave it on the bridge because that is on the default VLAN as well. I just want to test something now. IP address, put that there. IP address, put that there. Let's see, can I still ping across? No, don't do that. What am I doing? There we go. Alright, so the EIP is configured, it's on the same broadcast domain. Let's just quickly bring those machines into the same broadcast domain. So these are just VPCs. IP 192.168.88.10/24, and then I can use either .2 or .3 as gateways, but for this VPC I'll use .3 as a gateway. So 192.168.88.3, but the gateway is not that much of a requirement for the things that's on the same broadcast domain. Okay, that VPC is done. Let's do the other VPC quickly. So IP address, IP 192.168.88.11/24 with 192.168.88.2 is my gateway. So let's see, from VPC top, can I ping VCP bottom? Yes, I can. Okay, so the EOIP tunnel is established and it is able to route and do traffic. So your issue was specifically with, you mentioned something about the MTU sizes, Wolfbit. So what issue are you having? You said let's set the MTU to 1500 and let's see what happens. So let me bring these two devices back side to side. So typically what your issue is, if you look at the actual MTU that you're getting, it is taking into account the GRE payload on the tunnel. So there you get your actual MTU as 1458. So if we set that to 1500, that will cause some issues, and I'll explain to you just now why. But let's just see, is the stuff still working? Can my VPCs still get to each other? Let's see, other VPC, can I still ping? So I can still ping across and the MTU and stuff is working. But normally in this type of situation, what we want to do is, if we have the MTU here set as 1500, then you are going to have to increase the MTU size of your like links going out, actually, like the stuff that's having to carry the traffic, because our bridge is also going to be set to 1500, which is normal. Our EOIP was 58. Now we've forced it to 1500, but in theory, like what I would typically see in this scenario if I did this is either the tunnel would be unstable, or well, when I say unstable, it is like it would cause like packet loss, or some services just don't want to work at all. So in that case, we would probably have to just increase our actual MTU on our link going out. So in that case, we know that our ETH1 is now running at 1500 as well. And for that, we'd probably have to take into account what is the size for GRE on EOIP. So let's just go in here. Let's type in EOIP. Open this up. MTU should be set to 1500, blah, blah, blah. $42 byte overhead, which is how we got to that 58 number. So 8 byte for the 14 for Ether, 20 for IP. So I'm just not sure if we want to add the MTU size as 1542. But that seems a bit like overkill. I'm sure it's less. I actually feel like it is 24. But if we set the MTU of the UIP tunnel to 1500, then we need to increase the MTU size of the link where the traffic is going out, forming the tunnel, because it needs to be able to carry that traffic. But I mean, it's running like this right now. If we've just updated that. So let's see, can the PC still get to each other? Ping 192.168.88.11. Let's just see, is there any type of issues? I don't know if I can test fragmentation from here. I might want to run a Docker to test properly. That seems stable enough, but we're not really running anything except ICMP now. The stuff that I've seen issue with is if you like send out certain like a DHCP request, and things might get a bit weird. But I'd like to emulate and explore that as well. So in theory, yes, we would be limited to the upstream's queue because, well, both providers. So in theory, but this is just theory now, and this isn't how it actually plays out. Whatever our breakout is there and whatever link we have there, that is what we can get. But it also depends on what's running through our network and what we're actually providing to our customers, because typically we might just give them like a 10 meg or 20 meg link or whatever, because generally speaking, as a minimum from the IXP, you might bring in a 1 gig link to carry all of your bandwidth from the network. So that's a lot of bandwidth that you'd still have available from the IXPs, but the CPE would be limited to whatever that ISP dictates. So that they might, let's say, make it a 20 meg link. But again, since it's GRE and it adds that overhead to the payload, you will see a drop in throughput. It will be a little bit slower. I'd say it's about 10 to 20%. A good example would be, let's check this packet loss over UIP tunnel, because I know I've seen some posts where they do a good explanation of explaining this stuff. No, it's not this. Packet loss over GRE, McCritic. So here is this was the post that I saw. So here is a good performance indicator. As you could see, this guy has the same like link, and without GRE, this person was getting 28 meg, and when the traffic was running over the GRE, it dropped it by like 5 meg. So give or take, you will get, I won't say throughput issues, but it will be slower. And it's very hard for me to, I don't want to say very hard, but to properly test this over this network, I'd have to actually get proper licensing for these MikroTik devices, because on these trial accounts or trial routers, I'm limited to 1 meg per interface. And that's not a lot of bandwidth to play around with. You can exceed that so quickly, and the whole network becomes congested the moment you hit that 1 meg cap, which sucks. But at least we can test all of the other functions and features on the router. Like, I mean, we've done some pretty cool stuff now already with some free software. Pretty good. All right, I actually think it is getting late where I am. Fun fact, I got myself a green drinking water bottle, so I'm not sure if you can see what happens if I put this bottle in front of me, but I just want to take a sip of water. And then I probably want to call it a night, because it is 11 p.m. now, and I'd like to continue some more things in the next stream, and maybe look at creating some more tutorial videos, especially like on what Bogdan was asking a bit earlier about the PCC. It's fairly straightforward and easy, but I know if you're new to networking, like it's really confusing at the moment you think 2 ISPs and failover and stuff like that. But anyways, I'd like to thank everybody for watching. I am ending off the stream now. It was actually a pretty nice stream, and every time it feels like we're going a little bit further and we are labbing a little bit longer. The first stream was 1 hour, the previous one was 2 hours, and now we did a 3-hour stream. Bogdan, I will be streaming again next week, Tuesday at 8 p.m. UTC +2. I try and keep it consistent at that time or that date, and the tutorials come out whenever they come out, because at the end of the day I'm also a I'm almost a father, and I'm also working a full-time job, so it's quite difficult for me to find time sometimes to make videos. So that's why it feels to me having a stream like this in the evenings is a lot more worth it for me, because I can actually put some time in and do stuff. Because if I make a tutorial video, sometimes I'm so tired I don't want to like sit there and keep cutting stuff and whatnot. But anyways, guys, thanks for watching. I'll catch you in the next stream or the next tutorial. And again, please feel free to chat on Discord. I did post the link in the start of the video. And also I opened up memberships on YouTube, but I don't want to beg for memberships or anything like that. It's just if you feel like you want to support the channel in some way, then that is something you could do if you just join to be a member. Again, thanks for watching. Catch you in the next video. Bye bye.